Hello and welcome to one more day of the Advent of Code 2022. Today, day 13, I read the statement a couple of hours ago, but didn't start my programming yet. So let's copy the input first. Let's see what it looks like. Okay, these are pairs of lists, better. So let's copy it. Now let's edit 13.py and let's read this. So as you can see, these are groups of 2 lines. So what we can do is open 13.in.read.split. We split from a couple of new lines, and we could call these groups. We print groups, we get these pairs of lists, I guess. So here, what we want to do is for G in groups, I don't know why this is not indenting. This is weird. G dot split lines, AB, print A, print B. Okay, we have pairs of the lists. One thing we can do is evaluate each list. We get the same output, but now these are Python lists. So back to the statement, what we want to do is we want to check if how many packets are in the right order. So we could have a function called def ordered, which gets to lists left, right, or AB, maybe. I don't know why I don't get my indentation right. This is very annoying. Okay. One thing we need to see is if something is an integer, and I'm not sure how to do it. Okay, type equals int. Okay, and is instance, is this right? 3 int. Okay, these are 2 ways of checking the type. So here, what we want to do is, if both values are integers, the lower integer should come first. So if is instance a int and is instance b int, then return a minus equals b. If this is right, if this is true, they are ordered, right? Each instance of list is the other thing we want to check, right? So we could do here we could, so this would be an else if, right? If both are integers, this is the true. If this one is an integer, it means that the other one is not, right? So we could return ordered, and what we need to do is put it into a list. So what we need to do is, so A is an integer, so we compare A to B. And if B is the one that is an integer, then we compare A to B. So this is the first case, 2 integers, 1 integer not an integer. Then what if both are lists, right? So now we could assert, we're not going to assert now, but it doesn't matter. We can assert that A is a list and B is a list. If length of A is longer than length of B, if the first list is ordered, we already know that this is not correctly ordered because the first list has too many elements. Otherwise, what we're going to do is for AABB in zip AB, if AA is larger than BB, return false. Otherwise, we return true. So I think this might already work. And now what we want to do is, here we could say I in enumerate groups, P1 equals 0. What do we want to find here? We want to find the sum of the indices of those pairs. So and the indices start with 1. So what we want to do is if ordered A, B, they are ordered, then P1 plus equal I plus 1. Print P1. Let's see if this works. Okay, A, B, B. Okay, this is not right. So what we want to do is if ordered A, B, B. Let's see if this works. Too low. Okay. Now it's the time to take the example and play with the example. So let's edit 13.x. Let's paste this. Here we take x. 15. Here it says 13, so this is clearly wrong. Let's see what this says. Print ordered. So which ones are ordered? This one is not ordered. That is right. Okay, no. This one is ordered. So why are we not getting this? If this is an integer and this is an integer, print AB. Oh, wait. If not ordered, 11. Okay, this is not right. So, but this one is ordered, which is true. So this one is ordered. This one is in the right order, should be. So, okay, I did not do this right. The checking of the length of the list. So 2 versus 4, the lesser is smaller, so it is in the right order. So maybe if I understand correctly, this is not required. 25. Maybe yes. So the left side ran out of items. This is what I don't understand. The left side ran out of items. Okay, so it is in the right order. Per one, in the right order are not. So we run this. Right order, not. Right order. 1, 2, 3, 4 is in the right order. 5 is not. Why is this not? Right side ran out of items. Okay. So this. I don't understand the second. So this one, left side is smaller. And why does right side run out of items? In this case, right side runs out of items. But in this case, it doesn't say that right side ran out of items. I don't really understand this. If both values are list, compare the first value of each list, then the second value, and so on. If the left list runs out of items first, the items are in the right order. So if the right list runs out of items first, the inputs are not in the right order. If the lists are the same length and no comparison makes a decision about the order, continue checking the next part of the input. if the lists are of the same, so if both values are lists, compare the first value of each list, then the second, and so on. If the left list runs out of items first, the inputs are in the right order. If the second, so what we could do is compare each first, and then if the left list runs out of items first, so if the left return true. If length of B is larger than length of A, if the right list runs out of items are not, return false. If the lists are the same length and no comparison makes a decision about the order, continue checking. So what does it mean make a decision? The decision should be only false, right? It was the lower integer should come first. If the integer is higher than the right integer, otherwise are the same integer, continue checking. Okay. Okay, so I think the point is that if AA is less than, if ordered AA BB, return true. Okay. Okay, so this is not exactly true or false. This could be also unknown. Ordered equals. Okay, so it could be yes, no, or unknown. So if it's less than, it is ordered. Otherwise, we don't know. If A equals B, return -1. Else, return this. So here, if this is an integer, we return this, we return this. And now, if both are lists, we would say, if so, O is ordered AABB. If O equals -1, continue. If O, return true. If not, O, return false. $11. It should be 13. So this one is ordered. So the first one is ordered, right order. The second one should be in the right order. Why? Because 2 is less than 4. So if 2 is less than 4, here what we should say is compare A and B versus B. Sorry. Compare A versus B. So here, in this example, it is compare this versus this, compare 1 versus 1, 1 versus 1, 2, 3, 4 versus 4. Then mixed types, we continue comparison, 2, 3, 4 versus 4. And in this case, this one, we don't want 25. So this is 2, 3, 4 versus 4, 2 versus 4, ordered. That is right. This one here, not in the right order. Correct. This one is in the right order. That is correct. This one is in the right order. That is correct. 6 is in the right order. That is correct. This one is not in the right order. Why? Because this versus this versus this, right side ran out of items. Okay, so if right side ran out of items, if length of B of A is larger than length of B, return false. And now we got the 13. So let's check the input. 3359. No, this is too low. Okay, let's continue with the example. So this one is false, and this one is not in the right order. So this one is correct. The example is correct. 7 versus 0. Compare right side random titles, so they are not in the right order. So let's go against with the list. So if exactly one value is an integer, okay, no, that if both values are lists. If exactly one value is a list, convert the integer to a list which contains that integer and as its only value, then retry the comparison. For example, blah, blah, blah. So this is, if both values are integers, the lower integer should come first. If the left integer is lower than the right integer, the inputs are in the right order. If the left integer is higher, are not in the right order. Okay, so this is, otherwise the inputs are the same integer, continue checking the next part of the input. So these two, if A equals B is -1, otherwise return true or false. So here we return whatever it says for this, and then if there's a list. So if there's a list, we check the order. Compare the first value of each list, then the second value, and so on. What we're doing here. If the last list runs out of items first, the input is in the right order. So if length of A is then length of B, return true. If the right list runs out of items first, the input is not in the right order. Return false. If the lists are the same length and no comparison makes a decision about the order, continue checking the next part of the input. -1. I think now we change this slightly and maybe we get it right. Okay, let's check the second part. Now you just need to put all the packets, blah, 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 divider packets. What is the decoder key for the distress signal? The decoder key for this distress signal, okay, so what does this mean? You need to put all the packets in the right order. Disregard the blank lines in your list of received packets. The distress signal protocol also requires that you include 2 additional divider packets, this and this. Using the same rules as before, organize all packets, the ones in your list of received packets, as well as the 2 divider packets, into the correct order. Okay? Afterwards, locate the divider packets to find the decoder key. Okay, we need to multiply the index of these two. So what we need to do is, what we need to do here is to groups.append. Let's do the following. So what we need to do is packets equals a list. So we are going to do this, and to the packets we're going to add 2 packets. 2 and 6. Then for each one, packets append A and B. So now we have the packets. We're going to ignore all this, and we're going to hide all of this printing, okay? So what are we printing now? Print. I don't understand what we're printing now. Okay, here we're printing the packets. Okay, so what we want to do is packets dot sort key equals ordered. I think we need to sort this with a comparison function. So what does the dot sort do? Callable, blah, blah, blah. How do we sort with a comparison function in Python? I don't really know. Should we implement some kind of sorting of bubble sort or merge sort or whatever? How do we compare this in Python? So it seems one thing we can do is sorted packets CMP ordered. Does this work? This is not a valid function. So it seems this is what we used to use in Python too. And what we can use here is the key equals CMP to key order. Is that right? Okay, print packets. And now we can say packets dot index of 2, packet dot index of 6, print this, and let's check this for the example. So this is 0, 1, which is clearly not right. What does the comparison, is the comparison right? So packets equal packets sorted for P in packets, print P. Okay, 2, 6, blah, blah, blah. This is clearly not sorted. And also, I don't know if this is what we want to do. So the problem with this comparison function is that we should return something else. We should return positive, negative, or 0. So let's redefine this one. And here we're returning 0 if they are equal, 0 if they are equal, 0 if they are equal. If they are ordered, this is going to be A minus B. Ordered order, true is 1. Sorry, true is minus 1. False is 1. True is minus 1. False is 1. And now, this is the order we get, which is not right either. So here we said if ordered -1, else 1, -1, 1, 0. Is this what is wrong? I don't think so. No. Something is wrong with this comparison. What is the issue here? Ordered, if they are equal 0, what we could do to check if this ordered function is right, we could check this, and we could redefine this order up here, and instead of if ordered less than 0 for the example, and let's assert false. So here 31. So we didn't get this order function right. Okay, so this order function is 0 if they are equal. Sorry, this is b minus a. So this is ordered if a minus b, if a is smaller, this is negative. So this is the right thing. This is just returning the order. So if it's 0, continue. If less than 0, that's what. So else return O. I think this is what we want to do. Now we get the 13. Okay. Let's forget about this. 13. And now this is correctly ordered. 9, 13. This is not 9, 13. So what we want to do is print this number plus 1 times this number plus 1. 140. And let's go here. I think we got the solution now. Yeah, we did. Okay, so the trick here, and this is very, 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 very interesting, is to use the correct format, the correct ordering function, or let's call it CMP function for comparing two elements, right? So what we want to do is if CMP of two elements is less than 1, is negative, sorry, we want to do this. Compare, let's call it compare, and here let's call it compare. We remove this. Compare. So now we assert P1 equals whatever we sent, which is this. And we assert P2 equals whatever we submitted here, right? So here we can say P2 equals this. P2. Here we are. Okay, so now when reading this, we can also do something here. So what we can say here is, well, let's leave it for now. So if each instance this returns this, if instance this returns this, here we could just do this because it's the same. So if they are equal, the difference will be 0. Here we can do also if output does this work? Okay, this is the walrus operator. So if the comparison is 0, we continue, otherwise return 0. So we could also say different than 0. Instead of doing this, we could just write the compare twice, sorry. So this is right. And here, what we could do is return the length of A minus the length of B, right? And there we have the same. So we have simplified this comparison. For these lists, what we could do, we could say, packets, well, what we're doing here, right? So packets is an empty list. So packets is an empty list. And for each one, we are going to split lines and packets plus equal eval A, eval B. And then the first part what we can do is for I in range len packets 2, and we could do if compare packets I packets I plus 1. Okay, assertion error. What are we doing wrong here? Print I. Print packets. Okay. Assertion error. Oh, this is from 0 to len packets every 2. Okay. The comparison is not working here. So we add eval A, eval B. So we could also do AB in zip packets 1 like this. This is another way of doing the same. I don't know why this is wrong, but this would be AB. Still wrong. Print packets. Example. These are the packets in the example. Which is that right or not? 8989, blah blah blah. Should be right. Okay, so we got the assertion wrong. I don't exactly know why. maybe we want to undo the changes that we made on reading these packets. So for p in packets, print p. Is this list right? It is right. So let's print. Oh, wait. The problem is with I. This is one of the. So this is not right for sure. For I in range len packets. So from 0 to len of packets every 2, we compare packets I to packets I plus 1. Oh, and here, okay, now that's the issue. I divided the 2 plus 1. Okay, is that what we want? Print p1 13. Oh, now the assertion is wrong because we are not running against the input. Okay, now this works. So there was just some fixing we need to do with the indices here. So here we could of course simplify this. So another way of doing this is instead of I from here to here every 2, we could say this, and here we have 2 times I, 2 times I plus 2, and here we do I plus 1. This should be the same. It is the same. So this could also be done as a one-liner, right? So P1 equals the sum of I plus 1 for I in this range if this. If this. Valid. I guess there is something wrong here. Invalid syntax. Here we are. So this is part 1. And this is part 2. But for part 2, now we have packets already in a list. So what we can do is add these packets to a list. And then we sort them with this key. And then we do this. So here we could say, what are these separators? Divider. So the dividers are these, 2 and 6. So we just add these packets, we sort with this key, we get the index, and we assert. We could have this as part 2. We can move this import to the beginning. Here we could say we read the input. And what we're doing here is, well, we can forget about this. So this is just we split lines, eval A, eval B. We could map eval to this and say packets plus equal this. I guess, okay, it works. The fact that we're adding to a list already converts this to a list. I guess something else we could do instead of this, I mean, now that we're doing this, we could just read them before we try to read them as groups, but now we can just read them all together. So it would be for line in open 13.in if line. So we skip empty lines and we run this. Okay, eval line. What is the problem? Invalid syntax. What is the syntax? File string. Okay. So if line.strip, this is another way of saying this. So if line.strip is not empty, then we read all the packets. So this is, we simplified the reading of the input. Let's see if we can simplify this A and B. So here we would have, if is instance, is it, we already said if type of A equals int and type of B equals int. Is this a shorter way of comparing this? Well, it is. I mean, it's shorter for sure. Can we? I wonder if this works. I don't know if this works. It works. Okay. If I wasn't sure, so now we can compare with this. If type AB equals int, this here we are using if instead of else if because we are returning, so there's no need for having an else if, right? So here it is, if this is an int, we compare with AB. If this is an int, we compare with AB inside this converted to a list. And therefore, each element of ABB, we compare. If comparison is different to 0, so if they are not equal, then we return that value. Otherwise, we return the difference on the length. So this looks fine. I don't think we can simplify this much more. We could probably change the AB and the AABB and so on. But let's keep it for now. And then finally we return this list. Okay. Two integers, one integer, one list, two lists. Let's join that. And finally we have this. I like to simplify this in some way. So for 0 in length of packets divided by 2, compare. So another way we can do that is this way. Let's open a playground. So we have a list that has this 1, 2, 3, 4. If we do this, we get this 1, 3. And if we enumerate this is a generator, but if we make it a list, we have this. So I think that is better. So what we want to do, let's rewrite this, is for I AB in enumerate, not I index in enumerate or packets to, let's see, and we compare packets, or let's call this pi, so packet index. So this is the index plus 1. Integers, not slices. So what is the I? For pi, enumerate packets 2 to 1. Oh, so the packets 2 to 1. So this is the packet. So this is the packet. And this is the packets. So we zip packets 2 to 1 and packets 1. This, I guess, that's what would give us. So if we list zip L2 and L2, we get this 1, 2, 3, 4. So one way of doing this would be to enumerate, and if we enumerate, we get the I, let's say AB, I plus 1, compare A, compare B. It doesn't work, but because we have these packets, maybe we could just replace this. We can make it a one-liner. So I think this one is simpler, but this one also works. So what do we want to do? IAB. I think here we have less arithmetics. So I think this one is better. So we are summing I plus 1 for IAB in enumerate this if compare AB is less than equals to 0. So let's close this here. So we answer this as a one-liner, and this one we could say PLs equals sorted PS plus this with the key equals. Okay, so now here we're adding this list, these keys 2 and 6, and then we are sorting, and then we just need to take the index, right? So here we could say also divider, so D1 D2 equals to 6. We could do that, and here we could say D1 D2 D1 D2, if that makes sense. It didn't work. Okay, here there's a comma. Well, we added one line. I don't know if we added much more, so maybe let's leave it as it was. Many times do this, I go back and forth. So we sort this with this comparison, and then we take the index of 2, we take the index of the list 6, and then we multiply both of them. I think there's not much else we need to do in this problem. We learned many things today. So lessons learned. I think the most important one is using is using the compare function that returns negative, the compare function, which takes a and b, negative if a less than b, 0 if a equals b, and positive if a is larger than a. In summary, it returns a minus b. Right? That is what you expect if these were integers. If these were integers and you want to order them ascending. So this comparison function, we cannot send it. We cannot use it directly to sort, but we can use this functools dot compare to key. This is another thing we learned. With this function, we can use this custom comparison function to generate this key function, which is what you expect to use both the sorted and the sort functions. The third thing we used is we can check the variable type with type of x, or is instance of x, let's say int, or type equals int, for example. This is something else we learned. Then another trick we used is we iterate pairs of elements in a list with this zip here, right? This is not what we have usually done, which is the pairs of contiguous elements, but we have used this takes the first and second, third and fourth, fifth and sixth, and so on. What else did we learn? Well, we used the index function, list.index, to find the index of element x in a list. For example, this I think we have used previously. And we have used eval, the built-in function, to evaluate a string as Python. So these lists are converted directly to a list of integers. We used some recursion here for this comparison, but I think this is mostly it. Of course, other built-ins that we used in general, we used sum, sorted, enumerate, zip, eval, we already said, len, of course, eval, compare. So compare. Open. So we used many built-ins in this problem. Okay. And finally, well, this is interesting, but this also used as key parameter in sorted, sort, etc. So these functions get a key parameter, but we can use this compare function when using this sort. I had to pause this video a couple of times when I was recording it because I had to check the documentation, and I think that knowing how these compare functions work was extremely important in order to get this problem right. If you didn't have this knowledge or you couldn't find this quickly, it was pretty difficult to solve this problem because this is especially tailored at this kind of comparison function. Initially, I was trying to do this true or false, but true or false did not work because it's not only true or false. It's true. It's either smaller, larger, or equal, right? If they are equal, you need to keep comparing. If one is smaller or larger than the other, you can already stop. I hope you enjoyed today's video. Take care and see you tomorrow.